So this is a demonstration of how I normally conduct my online classes, as well as the tools that I use to try to deliver an effective lesson. The first tool that I depend on, of course, is Google Classroom, which is an interface between myself and my students, where I can post assignments, get feedback, review students' work, as well as maybe communicate, post textbooks and materials, and set deadlines. So let's take an example. This is my A-level math class. Here is the classwork. This is an existing class. And for example, this was an assignment which a student turned in. So I can actually take a look at Abdurrahman's work by opening this document which he uploaded on Google Class, and I can check his work and maybe provide feedback on what he did. So this is of course a very important tool, and it allows me to communicate with my students quite well. Another way I use Google Class is to post material. So let's take a look. So I have the syllabus here of the A-level course for this year. This is the syllabus for the 2021 exam, as well as the textbooks that we are going to use for the A-level math. This is the probability book and statistics, as well as the mechanics book, as well as Pure 1 and Pure 3. So a student can easily open one of these books online and use it to their satisfaction. I can also assign, of course, homework assignments from the book and have them submitted on Google Class as was previously shown. So this is what I use Google Class to do. The second and equally important tool that I use is Delta Math. Delta Math is a very nice website that allows me to give students assignments, like practice assignments, and have them solve questions, and I can also check their results. Let me show you how. So for example, this is what a student would see at their end if I assign them a question on solving equations. So here is a question that requires us to solve for x. Of course, this is pretty basic. However, it qualifies as an example even to more complex problems in higher levels. So in this case, of course, we have negative 3x equals negative 9. I prefer to use the annotation feature on Zoom in order to write on the screen, and then students can see my writing as I speak. So in this case, we are going to divide both sides by negative 3 in order to get rid of the coefficient of x. And we cancel out the numerator with the denominator on the left-hand side. We are left with x equals negative 9 over negative 3, which gives us positive 3. So the answer here is positive 3. If I attempt to type in the answer, I get that this is a correct answer. And the nice thing about Delta Math is that it also provides an in-depth explanation of each question. So here we have a good view of the steps required to reach the answer. Another nice feature in Delta Math is that the students have the option of watching a help video in order to review the topic or even understand it if they don't already understand it. So I always recommend to my students to watch the help video if they are not sure how to solve a problem. So Delta Math is an online question bank that already has a lot of nice practice problems, and I use those for my assignments. Here is a view of what I get as a teacher. So these are classes that I have. Let's take, for example, the A-level math class. Now, these are the assignments that I've assigned for this class to my student Abdul Rahman. And here is one assignment which he completed 84% of. I can check his score. So he completed 84% and got 84%, which means he's doing well in terms of correctness. And I can actually check his individual performance on each question. So for example, I can take a look at how many seconds or minutes he spent solving a question and whether he got it right or wrong. So this is one example of a question that Abdurrahman solved correctly, and so on and so forth. So this allows me to monitor student performance and assess where they are in terms of conceptual understanding and being able to apply the concepts taught in class. Now, while data math in and of itself is a very nice tool to use, I've even developed it more than the normal offering it provides, in that I've uploaded exam questions from the A-level syllabus. Let me show you what I mean by that. Let's try another question. Okay, so here, this is the question, and I can solve it quickly with you. The integral of x e to the power of negative 2x from 0 to half. Of course, this is an integration by parts problem. So if we have v and du and dv and u, we're going to place x here, and then the derivative would be 1, e power negative 2x here, and then the integral of that would be e power negative 2x over negative 2. Now the integral becomes as follows. We multiply this by that, so we get x e power negative 2x over negative 2 minus the integration of this multiplied by that, so e power negative 2x over negative 2. Of course, this integral is easy to evaluate because it's just one variable, one term. So e power negative 2x after integration becomes e power negative 2x over negative 2. And we get rid of this. So this is our answer before simplification, of course. Now I have here a negative 2 and a negative 2. So if I multiply those together, I get positive 4. And my answer is consisting of these two terms. So I now need to substitute from 0 to half. Let me rewrite this more neatly. As we said, our answer is x e power negative 2x over negative 2 minus e power negative 2x over 4. So this is a concise form of our answer. And we are integrating from 0 to half. These are our limits. So we begin by the upper limit. We plug in half instead of x. So we have half e power negative 2 times half over negative 2 minus e power negative 2 times half over 4. This is when x equals half. And then we subtract and we use x equals 0. Of course, x equals 0 here would give us 0 in this term, because 0 multiplied by anything just gives us 0. And e power negative 2 times 0 instead of x. So negative is equal to e power 0, which just gives me a 1. So it's as if I have minus negative 1 over 4. Right? So if we simplify our answer, we get the following. we have here minus negative 1 over 4. So this gives us positive 1 over 4. And we have here a 2 that can multiply the denominator here. So this becomes a 4. And e power negative 2 times half. Negative 2 times half is negative 1. So this can become negative 1. E power negative 2 times half here as well becomes e power negative 1. So e power negative 1 over negative 4 minus e power negative 1 over 4. This is as if I have minus e power negative 1 over 2. Hence, my answer is 1 over 4 minus e power negative 1 over 2, which is the correct answer. So this is a demonstration of how we can solve past exam questions using an online platform. Next, I'm going to show you another nice tool, which is ExamMate. ExamMate is a very nice online website, which allows me to check questions of a certain topic. So I can choose the topic I want. So for example, here, if I have mechanics, I can choose maybe energy, work, and power, and I can choose the years that I want to check out. So maybe 2015 and 2014, and maybe time zone 2, for example. I can look at these questions. So I have questions here that are all revolving around the topic of work, energy, and power. This question, and here is the answer, of course, the marking scheme answer to the question. So this is a very nice tool that we use in order to solve questions and maybe even self-check our answers to see whether they are correct or not. And of course, the same concept applies. Since I'm sharing this on screen, I can easily read the question wording with the students and then write on the screen how to answer the said question. This is ExamMate, and it's also a very nice tool to use. Another nice tool is Desmos graphic calculator, and this is basically a tool that I use in order to explain how graphs work. So here we have the graph of y equals ax squared plus c. So as a gets bigger, you see that the graph becomes smaller in a way, it's shrinking. Whereas if I decrease a, the graph becomes wider. So this has to do with the stretching of graphs, whereas the C has to do with the translation of graphs. So as I increase C, it looks like the graph is moving up, and as I decrease C, it looks like the graph is moving down. So this is also a nice tool to show how graphs change as I change certain parameters. These are all very nice visual aids and tools that I like to use in conducting my online classes. I hope this has been a constructive video. Thank you very much for your time.